Push that rock here with some math. Let's integrate functions composed of linear functions. So here we have secant squared composed of the linear function 5x plus 3. And in a typical book, we do u substitution. We let u be 5x plus 3, the inside function there. And then the differential of u is the derivative of this 5 times the differential of x, dx. And I have 1 dx, I don't have 5 dx's. So I rewrite my integrand, but I multiply by 1. So 1/5 of 5 is 1. So, and 1 times this integrand doesn't change it. But integration is a linear operator. I can kick this scalar out, and I have 1/5 times the integration of 5 times secant squared of the linear function. But I'm going to rewrite it as secant squared of the linear function times 5, because of course multiplication is commutative and I can change the order. But that shows me that du, which is the same thing as 5x, can take this place. So that can be replaced with du. And then this inside was all along going to be u, so that's secant squared of u. And so we're integrating secant squared of u with respect to u. And we have this scalar multiple out here. So it's going to be 1/5 times the antiderivative secant squared, which we should all know is tangent, because we derived last semester that the derivative of tangent is secant squared. We proved it with the quotient rule. And then we get our plus c, but we'll save that for the next step because we don't want to forget that we want to go back to the x talk. So u is the same thing as 5x plus 3 plus c. There we go. Now notice the thing that happens is the reciprocal of the slope of the linear function that's inside gets put out front. So we started with 5x plus 3. We integrated secant squared to get tangent of 5x plus 3. And then we just have the 1/5 out front, the slope, the reciprocal of the slope out front. I call this crawdad hole integration. You can only do it with a line, just like you can only fish for crawdads with a line. I mean, you can use a net, I guess, if you can draw them up, but you know, that's cheating. You drop your line with the bait tied to it or hooked to it into the crawdad hole, and that draws the crawdads up, and then you catch them. That's how you go fishing with crawdads. So here we can use crawdad hole integration. We have a line. Now, normally this would just be 1 over x. You know, you get the natural log of x. Our x is the line 2x plus 7. But this was a line, so I take the reciprocal of the slope and I put it out front. And then I add my plus c. That was very easy. Let's check it. So the vanishing log, let's take the derivative of that. The derivative of 1/2 times the natural log of 2x plus 7. You know, forget the plus c when you take derivative, it's 0. But this 1/2 comes out front, and you just multiply by whatever you get. So I'm going to multiply by whatever I get here. Now, when I differentiate natural log, it's vanishing log rule. You put the 2x plus 7 down here, and then you take the derivative of this, you put it up here. Oh yeah, this cancels with that, and I'm left with 1 over 2x plus 7. So yes, this is the antiderivative of this, because when I take the derivative of this, I get the integrand. Very good. So crawdad hole integration. Do one more example. So what's the antiderivative of cos normally? Well, it's sine, because the derivative of sine is cos. But of course I have to have an argument, and the argument's that linear argument there. But because it's a line, now I can only do this because it's a line. But because it's a line, you put the line here and you put the reciprocal of the slope of the line out front. So I put a 4 out here and then your plus c. Crawdad hole integration. It's easy. Math made simple. Some math.